Dr. Suphasiree is from the Department of Cognitive Psychology, Faculty of Psychology, Chulalongkorn University. She received her PhD from University of California, Davis, and she specializes in cognitive psychology and neuroscience. The title of her talk today is Language in Mind, a Scientific Approach. We are happy to have Dr. Suphasiree with us here today. Please join me in giving her a warm welcome.
ขอบคุณมากค่ะอาจารย์เดี๋ยวขอเริ่มต้นพูดเป็นภาษาไทยก่อนนะคะก็ขอบคุณทุกๆคนมากนะคะที่สละเวลามาฟังการบรรยายวันนี้ก็ขออนุญาตนำเสนอเป็นภาษาอังกฤษนะคะแต่ว่ายินดีที่จะตอบคำถามแล้วก็แลกเปลี่ยนเป็นภาษาไทยค่ะแล้วแต่ที่ผู้ฟังถนัดเลยค่ะเดี๋ยวขออนุญาตแชร์สกรีนก่อนนะคะ Can everybody see the slides that I have shared?
Yep. Yeah.
Thank you. Okay, so first of all, I would like to thank the Department of Linguistics at Chulalongkorn University for inviting me to talk about my research today. And thank you to the rest of the audience for taking the time out of your busy schedule to join me in today's talk. I'm very happy to be here to tell you about the research that I do. And if you have any questions or comments, please write them down throughout the talk, and I would be happy to address them at the end of the talk. So I recently completed my PhD in psychology from UC Davis just about 2 months ago. And then I came back to join the Department of Psychology at Chulalongkorn University. And if some of you may not be familiar with Davis, it's a city on the west coast of the United States, not too far from San Francisco. And it's known as the biking capital of the world. And so I have very nice memories of biking to campus to work every day. And before I begin this talk, I also would like to acknowledge the members of my lab at UC Davis who have helped me in various parts of the project that I will tell you about today. And this includes the various research assistants in our lab. These projects would not be possible without their hard work. And a special thank you to my advisor, Professor Fernanda Ferreira, who was my collaborator on all the projects that I'll tell you about, as well as my good friend and co-worker in the lab, Eleonora Bayer, who is a collaborator on one of the projects that I will tell you about today. So this is the outline for today's talk. I will begin by giving you a quick overview on what psycholinguistics is, as I know many of you might not be familiar with what this field is. And then I would like to introduce you to 3 of the projects that I have worked on at UC Davis. And through these 3 different projects, I hope to touch on some of the key ideas and theories in psycholinguistics and give you an idea of the kinds of research questions that the field is trying to answer, as well as give you examples of some of the experimental methods and tools that we use to gather our data to address these research questions. So let's begin with what is psycholinguistics? Well, the title of my talk is The Scientific Study of the Language and the Mind, and this is exactly what psycholinguistics is. This is the special name for this field that's dedicated to the study of language in the mind. So it's an interdisciplinary field that's relatively new. It contains 2 overlapping areas of research. First one being linguistics, which is the scientific study of language. And this field aims to explain and to classify different components of language. This would include different aspects such as the grammatical structures, the vocabulary, the meaning, the sounds of a language. All of these would be included in linguistics. And then we have cognitive psychology. This is the scientific study of the mental processes that happen in the mind and the brain, and how these mental processes relate to human behavior. So cognitive psychology would study topics, including language, but also other aspects such as memory, attention, decision-making, problem-solving. So the field views the brain as an information processing system, and it can process many different kinds of information, including linguistic information, visual information, auditory information. All of these aspects are studied under the heading of cognitive psychology. And so linguistics, to put it very simply, is the intersection between these two different fields. So it's an interdisciplinary field that began somewhere around the 1960s, and it's dedicated to understanding how language knowledge is represented in the mind. So in other words, how is language being used in real time, in the order of milliseconds, as you are either producing language, such as when you are speaking or when you are writing, and language comprehension as well. So what happens in the mind when you are listening to somebody speak or when you are reading some kind of text. So all of these would be included in the field of psycholinguistics. So psycho would come from the psychology part of the field, and linguistics would come from the linguistics component of the field. So psycholinguistics includes linguistics and cognitive psychology as the main components, but it also incorporates many other related fields. And I've given you two examples here. One is neuroscience. This is the study of the brain in particular, and neuroscience uses brain-based tools such as fMRI, EEG, or MEG. And based on measuring people's brain activity, we can infer the cognitive processes that gave rise to those brain activities as people are doing some kind of task. If it's from the aspect of psycholinguistics, then we would be interested in the brain activity that happens as people are either reading language or trying to understand spoken language. Other related fields includes computer science and artificial intelligence. And this is where we really see the practical applications of psycholinguistic research. So based on what we know from research in how the mind and the brain processes natural human language, it can be used to develop and to improve the natural language processing technology that are everywhere in our lives today. This would include voice assistants such as Siri or Google Assistant that comes with most smartphones that are bought these days. That kind of technology requires the computer to recognize a human's spoken voice and to do it as accurately as possible. Another example would be the automatic captioning on YouTube. I'm not sure if some of you have tried this out before, but if you watch a video on YouTube, there's a button labeled CC, and if you click on it, it will transcribe the speech that's being presented live as you're watching the video. So again, that kind of technology would require the computer to recognize the speech sounds that are being spoken and to put it together into words and into sentences for you to read as captions on the screen. Another example would be chatbots that are used. This can be used, for example, when you contact some customer service using an app or using some other mobile device to talk to a customer service, but instead of talking to a person, you are talking to a robot or a computer who has to understand what you are speaking or what you are typing and try to give you the help that you need. So again, that would require an understanding of what meaning you're trying to express using language. And all of these different fields that I've presented to you, they fall under the heading of cognitive science, which is they share the goal of investigating cognition, so how the mind and the brain works, from various different perspectives. Now looking at psycholinguistics a bit more specifically, The goal of this field is to answer these main questions. First of all, what are the cognitive and the neural mechanisms that support language comprehension as well as language production? And the goal is to develop and to test theories that can explain how language processing happens in real time as language is being encountered word by word, millisecond by millisecond. So in other words, the goal is to describe how these different aspects of language, which includes various different levels of linguistic knowledge, and try to understand how all of these information are processed and represented in the mind or in the brain. And the different levels include many different aspects that I have introduced previously. This includes the speech sounds in spoken language or the units of meaning in language, as well as the grammatical rules that are used to combine different words together, and how the brain generates the meaning of those sentences, how it combines meaning from each of the words and gives you an understanding of what the other person was trying to express. And hence, that is why I named my talk Language in the Mind, because I feel that it best describes what psycholinguistics as a field is. Another aspect of language that I have not mentioned before is this outermost layer called pragmatics. And this is the implicit meaning that goes beyond the literal meaning that is expressed in language. And this implicit meaning has to be inferred. It's not explicitly spoken, and the meaning can vary depending on the social context. And this aspect is one that is quite tricky for computers and robots to understand in the same way that humans do. But all of these represent the types and levels of linguistic knowledge that are somehow stored and represented and processed in our minds. Here are some examples of research questions that we address in psycholinguistics. One could be questions pertaining to the fluency with which people use language. So for example, what are the basic building blocks of language, and how are these linguistic units combined together in order to make the person able to use language in a fast and fluent way? Another question would be pertaining to aging. So as people get older, how does the language system change in relation to changes in their other cognitive domains, such as memory or their processing speed? Another aspect could be syntax or semantics, and this is pertaining to, for example, how your knowledge about the world can influence how you understand the events that are being expressed through language. And these three examples happen to be the exact research themes for the three projects that I will tell you about today. And I'll be going through the experimental data that addresses these three questions. But of course, there are many more other questions that are investigated in this field, such as the developmental aspect. So how do infants and children learn to understand and speak language? Or questions about bilingualism. So how do people who know two languages store and use those two separate language systems in their minds? Now, there are many different kinds of research methods and tools that we can use to address those kinds of research questions. And here I presented you three of the research methods that will be the methods that are used in the projects that I will tell you about today. So one kind of tool that we can use is something that's called eye tracking. So this is a device that can be used to measure people's eye movement patterns as they're looking at something on the screen. Since we're interested in language, we would present people with either a sentence or a paragraph and measure what happens as they're reading that passage. And from this measure, we can obtain exactly where the person is looking at on the screen and how long they're looking at the words on the screen and the pattern in which the eyes move as they're taking in the information. And in a well-controlled experiment these patterns about the differences in milliseconds in how long people look at each word can tell us about the kinds of cognitive processes that take place while the person was reading the language stimuli. If we don't have eye tracking, it's also possible to do a similar kind of research simply by using a computer or a laptop. So we can administer, for example, sentence comprehension tasks in which we present people with sentences or paragraphs, and we might measure the processing speed through how long people take to read each word, or we could measure how accurate they are in answering comprehension questions about the sentence they just read. And again, from these measures, we can infer what is happening in the mind or in the brain as they are processing the language. Another method would be text analysis or corpus analysis, which involves analyzing a large amount of text. Maybe it's text online or through a lot of books, and to see the kind of patterns that emerge from that kind of big data. In addition to those behavioral methods, there are also a lot of brain-based methods, which I won't go into detail, but I'll show you just some examples. One would be EEG, to measure the electrical activity at the scalp of the brain. Another would be fMRI, which measures the amount of blood flow to different brain areas while the participant is doing some kind of task inside the brain scanner. And from this, we obtain very pretty pictures of which brain areas were more or less active during those certain tasks. Other methods would be fMIRS and MEG, which are different ways of, again, measuring the activity of the brain as the person is doing some kind of task. The one downside of these tools is that they are very expensive, especially fMRI and MEG. And that's why in most research, if they don't have the funds to use brain-based methods, it is useful to use behavioral methods as a preliminary way of investigating the research questions that we have about how the brain processes language. This brings me to the first project that I would like to tell you about. And like I alluded to, this project pertains to the building blocks of language and how these units are combined in order to enable fast and fluent language use, the way that native speakers of that language would use that language. And when I say formulate language, I mean that there are patterns in the way people use language that seems to be repetitive. So on the one hand, language can be used to express any new sentence that you want. But evidence from corpus studies or text analyses show that the language that people use actually contains a lot of repetitive patterns. And it seems like the native speakers of that language seem to naturally know which kinds of words will go together and which kinds of words don't really go together. So for example, in English, if somebody asks you, "How are you?" it's very normal to just say, "I'm good," or "I'm doing good." And it's less native-like to say some other kind of similar response, such as, "My health is well." It might mean the same thing, but it's not as native-like, it's not as formulaic. And so this leads me to introduce two different approaches or theories that try to explain how language is represented and how it is used in the mind. On the one hand, we have what's called the words and rules approach. This is the classic way of viewing language. According to this view, we learn the vocabulary of the language, and then we also learn the grammar rules of that language. And these two things are stored separately in your mind. And anything that's larger than a word, such as phrases or idioms, they're thought to be rare examples that are stored in the mind. But the majority of what's in your mind are individual words and the rules for how you put the words together. There are recent studies, however, which suggest that maybe this is not the case. A more recent view is that there's actually no distinction between words and the grammar rules that are used to combine those words. So according to these newer approaches, they view that the mind stores representations of not only words, but also larger units such as phrases. And all of these linguistic units of different sizes are thought to be stored in the mind based on past experience with those linguistic units. And that's why it's called the usage-based approach. So under this view, people will store many different kinds of larger patterns of language. Sometimes they're called expressions or constructions. And then they propose that people use these larger linguistic units to be combined and to produce fast and fluent language. And now the question would be, which of these two views is a more accurate description of how the brain stores and processes linguistic units? Is it more like the words and rules approach, or is it more like the usage-based approach? So those two views that I told you about, they make different predictions about the processing of phrases. And based on recent research, the evidence actually supports the usage-based view of language. So for example, there have been many studies that have shown that phrases that are highly familiar and highly frequently used in a language are actually processed faster than similar phrases that are unfamiliar or novel. For example, in one study, they tested whether children were faster to repeat phrases that are very familiar to children, such as a drink of milk, compared to a similar phrase that is not as familiar and frequent to children, like a drink of tea. And they find that children are more accurate and they're also faster to repeat phrases that are familiar to them. And this has been shown in the way that adults process language as well. Familiar idioms, such as at the end of the day, are processed or read faster than similar phrases like at the end of the war. Another example would be similar phrases like don't have to worry. It's a very frequent combination or sequence of words, and they're read faster than similar phrases such as don't have to wait, which are less frequent when compared to these phrases. And the fact that the brain seems to process fast, familiar, frequent phrases faster seems to suggest that maybe the brain does store larger linguistic units. Because if the brain only stores individual words and the grammar rules, then people should not be sensitive to how frequent phrases occur, because phrases are thought to be combined every time you encounter that language. So these phrased frequency effects therefore seem to support the usage-based view of language. But at the same time, language is also open-ended. We don't just repeat the same expressions all the time. And so a question that we can ask is, how flexible are these larger linguistic units that are stored? Are they stored and retrieved as fixed units, or are they stored and used more flexibly? To address this question, we used an example of formulaic language called binomial phrases. And these are phrases in the form of A and B that occur very frequently in the language. Examples would include salt and pepper, bride and groom, cats and dogs, knife and fork. And these kinds of binomial phrases not only exist in English, but in many other kinds of languages as well, such as German, Spanish, or Russian. And the question we were interested in is, what happens when people read similar phrases that have a similar meaning, but the form of the phrase is slightly different, such as salt and also pepper, or salt as well as pepper? Are these variant forms of the binomial phrases also stored and processed as formulaic language, or are they treated as novel, unfamiliar phrases? And again, this is to address the question of how flexible these units can be stored and used. So here would be the rationale for this project. We're assuming that people store highly frequent phrases in their minds. We want to know what happens if people encounter variant binomials, such as these. And to do that, we compare the processing of these variant binomial phrases with unfamiliar phrases in which the last noun phrase has been changed so that the phrase is no longer familiar. Now, one thing to note is that these two types of phrases, they're not familiar nor frequent. That's something that's true for both of these phrases. So the interesting question is, would these variant binomials, which are not familiar and not frequent, would they be processed at the same speed as unfamiliar phrases? So they're treated as being both unfamiliar and not frequent. Or can the brain actually recognize that these variant forms are actually similar to the stored familiar phrase? And in turn, this might lead these variant forms to be processed faster than these unfamiliar phrases. That would provide evidence that the brain can store and use these larger units in a flexible way. So what we did in this study is we have 36 examples of those binomial phrases, and we manipulate the type of conjunction that joins the two nouns. We also manipulate the second noun to be the normal, frequent binomial noun, or we change it into something unfamiliar so that the phrase is no longer a frequent familiar one. So here would be the examples of the sentences that we present to the subjects. And we're interested in reading times on this second noun in the binomial. And the conditions we're most interested in are these variant forms. When the binomial has and also and as well as, do people still recognize this as a familiar phrase and process it faster than a similar but unfamiliar phrase? We presented those kinds of sentences using the eye tracking paradigm. So people read each sentence one at a time while their eye movements were being measured. And the experiment would go something like this. On the screen, they see a fixation dot. Then they're allowed to read the sentence for as long as they would like while their eye movements were being measured. And then they see some other types of sentences that are put in to conceal the purpose of the experiment so people don't notice a pattern in the sentences that they read. And from this paradigm, we obtain a measure of reading times on each single word. So the data might look something like this, where people fixate on some words but not others, and each circle would indicate exactly how many milliseconds people read that word. And in our case, we're interested in the second noun in the binomial phrase, and we want to compare whether this conjunction will influence how long people read that second noun. Another kind of paradigm we can use is cell-paced reading study. So we conducted the study using the same type of sentences, but we present these sentences on a laptop instead of using eye tracking. And here, people would be reading sentences one at a time, but they press a space bar to reveal each word. And when we measure how long they take to press this space bar, it can be a measure of how long they take to read that word. And again, we're interested in reading times on that second noun. Okay, so what kind of results did we find? We have two different types of measures here that are obtained from the eye tracking paradigm. For the purposes of this talk, the distinction is not important, but the important thing is when the conjunction is variant or different from the frequent form, do people still read the binomial noun faster than the unfamiliar noun? And we find that yes, people do read a familiar noun like pepper faster than an unfamiliar word like paprika, even when the binomial contains a conjunction that's different from the frequent form. So this suggests that the variant binomials like salt and also pepper or salt as well as pepper are recognized by the brain as being familiar phrases, even though the phrases themselves are not frequent. From the cell-based reading study, we see the same kind of evidence supporting that claim. So for the variant conjunctions, familiar binomial nouns such as pepper are read faster than an unfamiliar noun, even when the conjunction is not the frequent form and. So based on these results, we can conclude that variant forms of formulaic language seems to be processed faster than unfamiliar phrases. And if we bring back this diagram that I showed you before, it seems to provide evidence that when these variant forms of formulaic language are encountered, the brain does recognize that it's similar enough to the stored familiar and frequent form of phrases, such that the brain recognizes the similarity and can process these variant binomials in a flexible way, suggesting that a highly familiar phrase like salt and pepper is not stored as a fixed unit, but it can be used in a flexible way. It can accommodate certain variations in the words within the phrase. And overall, if we bring back the two theories that I showed you, it overall seems to support this usage-based approach to language, such that our past experience with language will determine how fast we process that linguistic unit, even if it's a phrase that's not just one individual word. And these results, again, would not be predicted by the words and rules approach, which states that past experience will determine the processing speed of only single words. If it's a phrase that's more than one word, the brain should not be sensitive to how frequently it occurs in language. So that's the end of project 1. Now we switch to project 2, which addresses a different kind of research question and also uses a different kind of experimental method. So again, the theme of this second project is how the language system changes as people get older. How does the language system change compared to other cognitive domains, such as memory and processing speed? In healthy cognitive aging, in which people don't have some kind of long-term disease, there are natural changes that occur in terms of sensory, cognitive, as well as linguistic changes. We can classify this into two ways. Some changes are more positive. For example, as people get older, they gain more knowledge and they gain more experience and expertise over the years. And one example from language would be that older adults tend to have a bigger vocabulary size across the lifespan compared to younger adults based on their experience. However, there are also some changes that occur that are not so positive. For example, a natural consequence of aging is that the visual system and the hearing system declines. So it's more difficult to see, whether up close or far, and it's also more difficult to hear clearly. Other changes include behavioral and cognitive slowing, in which older adults will move slower than younger adults, and the processing speed in which older adults process information in the brain might not be as fast as the younger adults. In terms of language changes, this might include difficulties in retrieving words when older adults are trying to speak. It might be more difficult for them to retrieve the exact word that they would like to communicate. In terms of language changes in particular, one interesting change that has been documented is that older adults tend to produce speech that is less fluent than younger adults. At least some studies have found this. Disfluencies are disruptions or interruptions in spoken language. Here's an example. So this is an interview of Donald Trump. And from this small segment of his interview, we can see that he makes several kinds of disfluencies when he spoke. So for example, he says, "This wasn't like this wasn't a game I was playing. So he repeats the words twice. And then he says, I'm not playing. You know, I wasn't playing. So in the middle of his sentence, he repairs the previous word that he says and replaces it with a new thought. And then he goes on to say, I wasn't playing chess or poker or anything. So another type of disfluency would be things like or that people say as they speak. All of these would be classified as disfluencies. And so studies have found that older adults seem to be more likely to produce these kinds of disfluencies as they speak. So they tend to say more uhs and ums when they speak. They tend to repeat words more when they speak. And they also have longer silent pauses in between words and in between sentences. And maybe this has something to do with how it is more difficult to them to retrieve the exact words that they want to say. So maybe these disfluencies are a way for them to gain more time to try to think of the word that they would like to say. So perhaps it's a strategy that's used like that. Now, one issue is the studies on disfluencies and aging have actually produced mixed results. Some studies have found that yes, disfluencies seem to increase as people get older, but many other studies did not find this kind of relationship. They find that the likelihood of producing disfluencies is similar when you compare younger people to older people. So why might this be? Why might there be this difference? There are many different kinds of reasons that can explain this, but one of the important reasons is many of these studies use cross-sectional design, meaning they compare different groups of people at different ages. So maybe one group at 20, one group at 30, one group at 50, and so on, and try to compare those. They did not use a longitudinal design, which would be better, in which we compare the same group of people at different ages. And this would eliminate any potential biases that are introduced in terms of individual differences in how they change over age. And so to address this limitation, this current project aims to investigate how disfluency changes over age or time using a longitudinal design. So again, we're following the very same group of individuals over time at different ages, and we want to measure the likelihood that they produce disfluencies, including the uhs and ums, the repeats, and the repairs in their speech. Based on past research, we would predict that older people should be more likely to make these kinds of disfluencies. So as they age, these very same individuals should be more likely to produce disfluencies. So we used a longitudinal design, and we want to find people who've been interviewed multiple times in their lives as the participants or sample in this study. And we have research assistants in the lab find these interviews, and then they listened to each of these interviews, and they manually transcribe or type the spoken language that was produced by that person. So they type down every single word, and then they manually count how many times the disfluencies occur in that language sample. And this took a very long time to do, over 2 years. So again, this project would not be possible without all the hard work of the research assistants in our lab. Now, where did we find interviews of people who've been interviewed multiple times over their lives? Well, luckily we have social media, in which there have been many publicly available videos on YouTube that record different interviews of the same people at different ages. So we took advantage of this, and we created our own corpus of speech, including interviews of people from various different occupations. And this includes many different occupations, such as actors, athletes, politicians, authors, and so on. And it would include people like Donald Trump or J.K. Rowling. And there were a total of 91 people that were selected for our study. We selected at least 3 interviews from each person. So for example, Oprah Winfrey would have 3 interviews. Donald Trump, since he's been interviewed many more times, we found 6 of his interviews, whereas other people might have 4 interviews, for example. So the number would range from 3 to 6 interviews. And each of those interviews was cut down so that it was only 2 minutes long. And those 2 minutes only contained the interviewee speaking. And there were a total of 325 interviews in this corpus. And again, each of these interviews would be at different ages of that person. For Oprah, for example, it would be at 37, at 53, and then again when she was 63. And the number of interviews and ages depends on what was available on YouTube. So this is not something that we were able to control for. But in any case, this method is very useful because it allows us to have a longitudinal design to get speech from people and follow them over the years, the very same group of people. And the age ranged from as young as 20 years old to up to 94 years old for some individuals. So based on those data, we are interested in the effect of age on disfluencies. So does disfluencies increase as people get older? We also include another measure, which is speech rate, because past research has found that older adults tend to speak more slowly than younger adults. And this has been a very robust finding that has been found in the literature. So we include this as well. And we analyze the 3 different types of disfluencies separately. So filled pauses, repeats, and repairs. Let's look at filled pauses first. These graphs that I'm going to show you, each gray line represents one person's data across their age. So this line, for example, might be someone who was interviewed first somewhere around 60, and then somewhere around here, and then somewhere around here. So this spaghetti plot shows you all the 91 individuals combined, and the red line shows you the average across all those individuals. And for example, we find that there's no effect of age for filled pauses. As people get older, the likelihood of saying or in their speech does not change. What does change is filled pauses when we use the speech rate as the predictor. This is showing that the slower the speech rate, the slower the people speak, the more likely they are to say or to say in their speech. Or you look at repeats, now there's an effect of age, such that the older people got, there was a slightly higher likelihood for them to repeat the words in their speech. And although the line looks a little bit flat, when you do the statistical analyses, this was actually significant. There was a slight increase in the number of repeats that were made over age. However, there was no effect of speech rate on repeats. For repairs, there was no effect of age nor speech rate. None of these predictors were able to predict the likelihood that people will repair something that they already said. If we put together all these results, it looks something like this. As people get older, they're more likely to repeat their words. This is consistent with past research showing that maybe it's a strategy for them to gain time to retrieve words. Age also predicts speech rate, such that older people will speak more slowly compared to younger people. And speaking slowly, in turn, predicts an increase in saying or in the speech. And no variable predicts repairs. So given this picture, it's kind of unclear what is happening. And one limitation from this study is that we were not able to perform cognitive tasks on those interviewees. So in other words, we weren't there at the time of interview to give them measures such as processing speed or memory abilities. And so given this limitation, we thought of one way that we can address this. And that is, we can measure other related aspects of their speech which can help us understand how the repairs and the filled pauses are related to older age. And the way we do this is we use an online tool called Cometrics. This tool allows you to put in any text that you want, and it will give you various properties of that text. An advantage is it's an automated system, so it saves time and it doesn't require a human being to code these aspects manually. We obtain interesting measures such as how frequently or common are the speaker's words that are used. Do they tend to be common words, or do they tend to be words that are less commonly used in the language overall? We can also measure how long the sentences are on average that person spoke in the interview, as well as how diverse the speaker's words are. So some interviews might contain a very small set of words that tend to be used over and over. Other interviews might contain various different kinds of words that are used in the same interview. So we use these measures that we collected, and we want to know how those variables relate to the disfluencies and how they relate to age as well as speech rate. And we find that, interestingly, each of those three aspects turn out to be related to 3 different types of disfluencies separately. For example, having longer sentences seems to predict more likelihood of saying or Using more frequent words in the speech seems to predict more likelihood of repeating words. And using a more diverse vocabulary when speaking seems to predict a less likelihood of repairing what they just said. Also, speaking slowly predicted a number of those speech aspects, such as it predicts speaking words that are lower in frequency or not as common, and it also predicts a likelihood to use a more diverse set of vocabulary when speaking. Now, bringing back the diagram that I showed you before, those exploratory analyses can be fit in like this. So longer sentence length seems to be associated with the likelihood of producing more uhs and ums. The frequency of the words that are used seems to be related to repeats in particular. And the diversity of the vocabulary that's being used seems to be related to the likelihood of repairing what was said. So these different aspects, interestingly, turn out to be related to very different types of disfluencies. So from this project, the main results, again, are that age does predict repeats, such that the older people are, the more likely they are to repeat words. This is consistent with what we predicted at the beginning. But age is not related to other types of disfluencies. As people got older, they weren't more likely to say uhs or ums, and they weren't more likely to repair what they just said, which is contrary to what we predicted. And age predicted slower speech, consistent with past research, which has shown that older adults are more likely to speak slowly compared to younger adults. And slower speech seems to predict the likelihood of saying uhs or ums. However, there was no direct relationship between age and filled pauses. It was only when slower speech was included that this variable predicted filled pauses. And from the exploratory results that we ran using the Cometrics variables, it turns out that different types of disfluencies were related to different aspects of speaking. So each disfluency was separately related to how long the sentence was, how common the words were used, and how diverse the vocabulary was. There are 2 important conclusions that can be made from these results. First of all, it seems that how fluency changes over age seems to depend on which kind of disfluency we're measuring. And this evidence comes from the exploratory analyses which showed that each type of disfluency was predicted by a different measure of speech characteristic, suggesting that maybe each type of disfluency is caused by different cognitive mechanisms, not just one. It also suggests that the fact that older adults may speak less fluently may not be due to an overall cognitive decline in aging. Instead, it might reflect a trade-off between having more vocabulary knowledge that are stored and the difficulty at which those words can be retrieved when the older adults are speaking. If I bring back this table that I showed you at the beginning of the positive and not so positive changes that come with aging, our results can be fit in like this. So we find that aging seems to be related to using rarer and more diverse vocabulary, which was shown from the exploratory analyses. So that's a good change. But there were also some negative changes. So the older people were, the more likely they were to repeat the words they just said. They were also more likely to speak slowly. And perhaps they were more likely to produce uhs and ums when they speak, although this was predicted by speech rate and not by age itself. Overall, then, this seems to support the idea that there's a trade-off between the amount of knowledge that's stored in the mind as people get older. The more knowledge is stored, perhaps the more difficult it is for the mind to retrieve those words as the person is speaking. So it might not be due to an overall cognitive decline or slowing, but is simply due to this trade-off between something that you gain when you get older and something that you have to give up in exchange for that. And now we come to project 3, which is on the understanding of linguistic events. Again, the question here, or the theme of this research, is how does our conceptual knowledge about the world influence how we understand linguistic events? What do we mean by linguistic events? Well, we use language to communicate about events all the time. Whenever we watch something on TV or on the laptop, we have to understand events that are communicated in the people who are speaking. Or when we talk to a friend, we're using language to communicate about something that happened, about something we read or something we experienced. And based on these experiences, we need to infer what event is being communicated in each of the sentences that are being produced. And so, more specifically, a sentence conveys a certain linguistic event. A sentence will tell you who did what to whom, what were the actors that were involved, and what is the action or the verb that happened. This might include also other information such as where the event took place, when it took place, or how it took place. And the goal of listening or speaking would be to understand the event that's being communicated through language. Now, the task that the brain has to do is it needs to analyze the syntax or the sentence structure of the sentence in order to understand the meaning or the event that's being expressed. For example, in a sentence like the boy pushed the girl, the brain needs to analyze that this is an active voice sentence in which this first noun, the boy, is the one doing the action of pushing, and the girl's the one who's being pushed. Take another sentence such as, the girl was pushed by the boy. In this case, the brain has to analyze that the syntax of the sentence, it's a passive voice sentence, such that the first noun, the girl, is actually the one who's being pushed, the one who's being done to. And the one who's doing the action is actually the second noun in the sentence. It's actually the boy who's doing the pushing. So understanding the syntax or the grammatical structure of the sentence is very important to understanding the meaning behind that sentence. Now, at the same time, even though syntax is very important to understanding language, another thing about language is that when we communicate using language, it tends to occur under imperfect and challenging conditions. What do I mean by that? Well, when we communicate, usually, especially in spoken language, it occurs under time pressure. You have to quickly understand what's being said. You have to prepare your response to the person, and you have to anticipate what the other person will respond, and so on. It also tends to occur under noisy environments. Maybe there's a lot of noise outside in the environment. Maybe there are other people talking as well. Maybe you're trying to listen to a lecture through Zoom and there's connectivity problems in the internet, so you can't really understand what the other person is saying. Sometimes speakers and writers make mistakes when they speak. Sometimes you don't always pay full attention. Sometimes you pay more attention, other times your mind wander and you kind of miss what the person just said. Or there might be other hearing or listening problems that prevent people from fully comprehending the linguistic sentence for what it is. Given these challenges of communication, there have been recent models of language which proposes that maybe we don't always interpret a sentence just based on the syntax or grammatical structure. Maybe we can rely on our expectations to interpret the language that we are reading or listening to, which can help us cope with the challenges in noisy communication. So let's say we have this sensory evidence from what you are hearing in speech. This is the linguistic signal, and what you're hearing is somebody saying, "The dog was bitten by the man." Now, if you correctly analyze the syntax of the sentence, it gives you this kind of weird meaning that the man is the one biting the dog. And in your mind, you might picture something weird like this. But at the same time, you have expectations about what's likely in the world. You know that dogs are more likely to bite people, not the other way around. So the task of the brain then is to integrate these two sources of information. You have to understand what the current evidence or linguistic input is saying from the syntax. You also have to combine information from what you think is the most likely meaning that the person intended to express, given your knowledge of the world. This view is supported by past research, which has shown that expectations can distort people's understanding of sentences. And this is most likely when the sentence is complex in structure, such as passive sentences. Passives are complex because, again, you have to understand that the first noun is not the person doing the action, but it's the second noun in the sentence, which is the reverse of what we usually use in language. So in previous research, they compared sentences that varied in the structure, either a passive or an active sentence. And if you switch the two nouns around, it gives you two different kinds of meaning. In one order, the meaning is plausible or it makes sense given your knowledge of the world. In a different order, it doesn't make sense, like the dog bit the man versus the man bit the dog. One meaning is clearly more likely than the other. When people read or listen to these sentences, past research has found that people make a lot of mistakes when they try to understand these sentences. So when they try to answer a question such as, who was the one doing the biting in the sentence you just read? People make a lot of mistakes in the passive sentences compared to the active sentences. So for these conditions, people are less accurate at understanding what the sentence meant. This led to the idea of something called shallow processing, which is that maybe people don't always interpret sentences according to their syntax. Under an imperfect communication setting, maybe people just rely on what meaning is most consistent with their expectations, even if that's not what the person actually said. Now, one question we can ask is, why do people tend to misinterpret those passive sentences? What is the specific cognitive mechanism that can explain why people tend to make those kinds of errors? This can tell us about how the brain integrates information from the sensory evidence with the expectations that they have based on their knowledge of the world. One possibility is maybe the brain considers several possible meanings at once. So specifically, maybe these misinterpretations occur especially when there's a highly plausible meaning that can compete with the actual meaning of the sentence based on the syntax. For a passive sentence, like the dog was bitten by the man, if you rely on syntax, the brain would give you this kind of weird meaning. But if you rely on your expectations, again, you should expect that, wait, maybe they meant the dog was the one doing the biting. According to this hypothesis, maybe the likelihood that you misinterpret a sentence like this will directly depend on how plausible this alternative or competing meaning is compared to the actual meaning that was being said in the sentence. So to test that hypothesis in this current project, we use the same design as the previous study that I showed you about on passive sentences. And we have 144 different types of sentences like those. And each one varies in whether it was an active or passive sentence and whether the meaning that you get from the order of the two nouns, does the meaning of the sentence make sense? Is it plausible or is it implausible? So we test this hypothesis by measuring the plausibility of the two competing events. And we'll use these ratings to predict how accurate people are in understanding those sentences. So one way would be just give people each of the sentences and have them rate. How likely is it for this event to happen in the world? For the dog bit the man, rate it on a scale of 1 to 7, from very plausible to very strange. Another way is to directly compare the two events against each other. Give them the dog bit the man on one side, the man bit the dog on the other side, and have them move the slider scale to say, if they move it here, it means this sentence is this much more likely than this event, with the middle being the two are equally likely events. And then to analyze the data in numbers, we simply use a scale of -7 to 7 to quantify this difference in plausibility or likelihood of the event. Now, in the main experiment, we present those sentences to participants. Either they read the sentence or they listened to the sentence. And then we ask them, who was the one doing the action in that sentence you just read? And then they type in a response. And this goes on until all sentences were read. And again, we're interested in how accurate are their understanding of those sentences. Does it vary depending on whether it's an active or passive? And does it depend on the plausibility or likelihood of the competing meaning, the one that's not actually what's being said? So here's the data. The top one shows you the ratings from the scale of 1 to 7, and accuracy is plotted on the y-axis. 7 means that it was a sentence whose meaning was strange, but the competing meaning was highly plausible. Like the sentence actually said, the dog was bitten by the man, but the competing meaning, the dog biting the man, was rated as very highly likely, like 7. And the bottom would be the slider scale from -7 to 7. And again, we predict that the higher the rating, the worse people should be in understanding that sentence. And that's exactly what we find. The more likely that alternative meaning is, the less accurate people are at understanding the meaning of that sentence. Seems to support our hypothesis that maybe the expectations that we have really guide our understanding of language. Now, there's another thing I haven't told you about, which is we also included another condition known as the symmetrical sentences. In these ones, it was designed so that whether you switch the nouns around, it doesn't change the likelihood of the event. For example, a customer thanking a clerk is equally likely to a clerk thanking a customer. So the two events are equally likely. what happens when people try to understand these sentences? It turns out that when they try to understand these symmetrical sentences, it doesn't depend on the meaning of the alternative interpretation. Seems to suggest that people are not relying on strong expectations in guiding their understanding when the sentences are already plausible. So that's not what we predicted based on our hypothesis. I will skip this in the interest of time and skip to here, where I bring you back the model that I showed you before and tell you that for sentences whose meaning is strange or unlikely, like the dog was bitten by the man, it does seem like your expectations strongly guide how you would interpret the meaning of that sentence. You would rely on your knowledge of what's likely in the world to determine what meaning was said by the person. So you might be likely to not interpret it according to the syntax, but interpret it according to your own expectations. But the story is complicated because this wasn't observed for sentences whose meaning was already plausible. So if the meaning was already making sense, like the customer was thanked by the clerk, then you just rely on the syntax to get the correct intended interpretation based on the sensory evidence. So I hope this gives you an idea of what psycholinguistics is, what kind of questions we're trying to answer, and what kinds of tools and methods we use to answer these kinds of questions. And here I have summarized for you the take-home message from the 3 projects that I talked about. In terms of fluency, it seems that the brain is not only storing words and grammatical rules, but it includes multi-word units like phrases as well. And these units can be stored and used in a flexible way, not in a fixed way. In terms of aging, it seems that some types of disfluencies do increase as people get older. We found evidence for this with repeats. And overall, it suggests a trade-off between gaining knowledge and difficulty in retrieving words, not due to cognitive decline as people age. And in terms of the 3rd project, it seems that our expectations can distort how we understand linguistic events. But this only happens when there's a good reason to do so, such as when the sentence is conveying something that's unlikely. And it also suggests that maybe the brain considers only one meaning at a time, and there's no competition from the alternative meaning. And that's all I have for you today. Thank you for joining me for this talk, and I would be very happy to hear your thoughts and questions on anything that I've talked about.
Since Ajahn Thiraphon might have to leave early today, I'll take it from here. I would first really like to thank Dr. Suphasiree Chantavarin very much for such an informative and stimulating talk. And now I'd like to open the floor for questions. As Ajahn Suphasiree said, that she could take questions in both Thai and English. So please ask away.
ภาษาไทยก็ได้ค่ะ ภาษาอะไรก็ได้ค่ะ
Okay, there's one question here. May I ask what the main difference is between eye tracking and self-paced reading and why this research chose both of them? Thank you.
That is a very, very good question, and I will be happy to answer this. So the main difference really is eye tracking is a much more sensitive measure of reading, because when we use eye tracking, we get very precise information about how long people look at that word at the fixation level. So at the very pixel that they look at, and then do they move their eyes back? Do they move their eyes to the front? How many times they do that? And so it gives you a very detailed information about eye movements as people read. Self-paced reading is a much easier way to collect reading data, but it only gives you one kind of data, just how long people took to read that one word. it can't tell you about where people looked exactly on the screen or whether they went back to read something else. And the advantage of self-paced reading is it's a lot easier to give to people. It costs a lot less money. You don't need an eye tracker. And in this way, you can collect a lot more data from many participants. So with eye tracking, I could collect maybe 40 or 50 people just because of time and resources. But self-paced reading, I can collect 200 participants very quickly because I just post a link online and people just read those sentences. So one reason why we included both is because we needed to replicate one of the studies in that project, and we needed a way to collect more data quickly. Yeah, but that's not to say it's not informative. Self-paced reading is a very standard paradigm that is used in psycholinguistics as a measure of reading times. Yeah, thank you for the great question.
Okay, another question. In Thailand, where can I find an eye tracker to be used in my research?
That is a good question. I would like to know too.
Depending on your institution, I guess.
Yeah, I think so too.
I'm not sure, but I heard that there might be one at Satsin. Yeah, there's like that, like marketing research or something like that. I'm not quite sure.
Yes, eye tracking can also be used not only for language, but for marketing research too, where people are looking when they go to a shelf at the supermarket. And if you find that people look more at this location, you can charge more for people to put products at that location. Yes.
And I thought that you mentioned that Department of Psychology has one too, maybe?
I believe so. I think so, but I am not sure yet because I haven't gone back to the department since I came back due to COVID. But yes, I believe we might have one.
Okay. Thank you. Okay. Ajahn Chaipat.
Hi. So where to start, because we also have eye tracker if you're interested in, but not iLink 1000 that you use, because that one costs like a million baht already. Such an interesting talk. Thanks a lot. I'm interested, especially in the second experiment. Do you think the way that you approach is very creative? Do you think there's a problem with that a little, or limitation that you want to address? And also, do you also trying to contrast it with developmental trajectory? Because that will be fun to see how the change in elderly compared to when the kids start to learn, when they build vocab, but you don't have the same retrieval trade-off. That will be such a cool opportunity to test your hypothesis.
So testing speech in children too. Yes, that would be very interesting. If there was a way to collect speech of children and compare that, that would be, yes, very.
Or maybe you can also like collect different aspect of cognition that will be done in the lab for sure, but then there will be a chance for you to measure like executive function or working memory, because that will be the one of the main cognitive faculty that's gonna affect the result.
Yes, I think it would make the study stronger too by providing information about measuring those cognitive aspects directly. And I think I know what you might be thinking of when you say limitations. And
Donald Trump.
If I might guess, based on what when we presented these research in the past, the main comment that we get is, well, how do we know this is true in normal population? These are like famous people that have been, highly successful. Maybe they're just practice in speaking, and maybe the topic that they speak just changes as they get older. So there are a lot of things we cannot control from this study, which shows you the trade-off of using a very controlled design, like the first and the third project, compared to this more naturalistic design where there are a lot of variables that we can't control for. So I would have two comments in response to that. One is we did our best to try to reduce bias by having research assistants who don't know anything about our topic and research question, and have them pick the people that should be in our sample. Just find some people who have many interviews and let's see what the data shows. And another thing in response to that would be, the good news is there has been one other longitudinal study on how disfluencies change over age. That one used telephone conversations as their data. So normal people just speaking on the telephone, let's see whether they produce more disfluencies. And we find that for that, their results are very similar to ours. So they find that age predicts repeats and also predicts speech rate, but that speech rate predicts filled pauses. So as well as the additional measures of speech like sentence length, word frequency, all the results seem to be consistent with what we found. So that makes us a bit more reassured that maybe our results can generalize to other populations who are just not famous and successful.
Yeah, thank you. Not that I don't like that experiment. I actually like it a lot. So I guess in this case, you win because you're more creative and spend less money and came to the same conclusion that they have to spend like many years, I guess.
Yes, though a lot of people may not be convinced because of the limitations of it. Yes.
But one thing that you might already looked is that maybe you can break them into different kind of occupations that they did. You find something interesting? Maybe singer would be different from politician, or I don't know.
I think the challenge we had was there were about 7 to 10 different occupations.
I see.
And it was
you have like 3 of them in each.
Yes.
Right.
Yes. But in future research, I think that should be investigated. It's very interesting.
All right. Thank you. Very interesting.
Thank you. Thank you for the questions.
Since we're already on that topic, I have a question about that. Like, do you think disfluencies are manifested differently cross-linguistically? Like, do you think that like people with Thai might adopt different strategies? Like they might just use more instead of like repeating what they used before, or you think that this is universal?
I think that would be so interesting to investigate. Because to my knowledge, I don't know of any studies that have been done on disfluencies in Thai. And I think maybe there could be those differences that we just have not found out about. Like one thing I don't think Thai people normally say as much as, or at least that's how I feel, but this would have to be tested, but I'm not too sure. Yeah, we would have to investigate that.
It's more like, I don't know, maybe influenced by English, I guess, but usually people would just I think. Okay, another question from the audience. Could you please give some brief information on the online tool Cometrics?
Yes, sure. Let me see if I can find a link for that. It's a very old tool, I have to say. Like if you go to the website, you might be a bit shocked. It looks very old-fashioned, like from the 1990s, but it actually works. You just have to copy paste a certain amount of text in there. It will give you a huge amount of information in terms of different characteristics of that speech. So I will show you the link right here. And it's been used a lot in research on not sentence processing, but on discourse processing. So many sentences together, not just one, because it can tell you things like how coherent is the text from one sentence to another overall. Does this whole paragraph kind of make sense and go together based on the kinds of words that are used and the kinds of grammatical structures that are used in that speech? Yeah.
And it's only available for English, or maybe it's other languages?
Yes, for now, I think it's only for English, as far as I know. I'm not sure if there's something similar for Thai. Yes. That would be cool to develop, though.
Yeah, that would be cool to develop. And I guess we have to learn about how to make that matrix, like not just whether we have it or not, but how to make one ourselves.
Yes, that's right.
อาจารย์ธีรพรเชิญค่ะ
ค่ะอาจารย์
First of all, thank you so much for such an interesting talk. Yeah, I have just a quick question about the binomial study.
Yes.
binomial noun studies. I wonder if you found any effect of conjunctions, like the differences between and also and as well as something that like that. Yeah.
Yes. Other conjunctions, is that what you mean?
Oh, I mean the different maybe I didn't catch it on the slides. So the difference between and also and as well as, they are the two conjunctions that you were using apart from the typical and, right?
So did we find differences between those two strange ones, right?
Right.
Actually, we did not. Interestingly, those two differed from the and, the normal typical one, but those two other ones did not differ from each other, except for very subtle differences. Like in the reading times, we find that if we use and also, people are more likely to go back to reread earlier parts of the sentence. And we think it means maybe people are not sure what happens when they see salt and also blank. Like, will it be a verb? Will it be a noun? Is it a new clause? Maybe people are not sure and they have to go back and reread the previous part of the sentence to make sense of it. So we think maybe that's why there's a difference. But other than that, I think the two were very similar, because we also measured what happens if we give people the sentence up until the conjunction and give them a blank and say, just write the first word that comes to your mind. So people are very likely to put the word pepper in like salt and blank, but with salt and also blank or salt as well as blank, people are also still likely to say pepper, but this likelihood is slightly decreased, showing that people do notice that there's something that's not the same as what I'm used to in the language. But it's a very small, subtle difference that was not found in the reading time measures when people process it in real time. We only find it in the kind of measure that really directly asks people, what do you think this sentence means? Mm-hmm.
Thank you.
Yes, you're welcome.
There's another question from the floor. I think he or she might wonder about a different group of participants. If the participants were second language learners, would the results be any different? I'm not sure which experiment.
Yeah, which project, right? Okay, well, let's consider the first project on formulaic language. There has actually been a lot of research on what happens when a second non-native speaker participates in the study and tries to understand these sentences. We find actually that if you're not a native speaker of a language, you're less likely to be sensitive to the frequency of phrases. So if you read something like don't have to worry versus don't have to wait, in which the first one is a lot more common in language, if you're not a native speaker, you just read those two at about the same speed. You don't show this processing advantage for the frequent phrase, showing that you really need the experience with language in order for it to be strongly represented in your mind. So definitely there's a difference if there's a second native speaker instead. Second project, yes, definitely. That's one thing that I did not mention, but we made sure everybody in the study was a native English speaker. This is just to make sure we control for the influence of another language. We want to make sure that all of them are equally proficient in English, that they're not being disfluent because they're just not good at the language. But it would be interesting to find out how this changes in people who are bilingual or can speak even more than two languages, to see how their disfluencies change over age. And like Ajahn Natanan said, maybe there will be some cross-linguistic differences that come up based on which language they're using in that moment. I would predict that if they are not very good at one language compared to another one, they should be more likely to be disfluent in that one. Example, I am more used to English based on my education, and I use Thai less frequently. So when I speak Thai, I would expect myself to make more disfluencies because I have a harder time trying to retrieve the exact words that I want to express. So that would be my guess on that. That's a great question. Thank you.
I saw that like Ajahn Chaipat's lab has another member. Do you want to ask a question, or you just want to say hi?
Oh, no, I didn't want to say hi. No, yeah, I can say hi, but I mean, I meant to ask a question. Sorry, I'm one of Ajahn Chaipat lab member, so I just use his account for now. So basically, I'm just interested in the experimental design in the project too. That you just went through on YouTube and then you select interview in the YouTube. So I'm just curious about how the selection procedure in the interview, like whether you did it by computer or you did it by humans, and what are the criteria for those kind of interview? Because, for example, J.K. Rowling has tons of interview in my point of view. So I'm just interested how you pick that to make sure that it's not biased or it's enough to be representative for that individual person.
Yes, that's a very good question. Thank you. It was not automated. We have our research assistants in the lab pick the interviews for us. We give them a certain set of instructions of what the criteria should be. So just look up interviews of different people. Make sure you find at least 3 so that we can track their changes over age, and find as many as you can that's on YouTube. And find one that you can find the section of speech where the person is speaking for at least 2 minutes with like no other interruptions. And there can be interruptions from like too much background noise or other people talking so that it's hard to transcribe what the speech is. And that we need to be able to identify when they did the interview. This was a big challenge. A lot of videos are posted and we don't know what year it was done, how old the person was. So that rules out a lot of interviews that were included in our study. Let's see what other aspects. I think those were mainly it. We left it up to the research assistants to just look up a list of different people who have been interviewed many times in their lives. And as long as you can find the ones that fit these criteria, then we just try to look at the data. But a lot of it ends up not meeting many of our criteria, and we excluded like 20 to 30 different interviewees who just didn't meet our specific criteria. Oh, and then the interviews have to be at least 7 years apart to see the difference in age. So if there's one at 32 and another one at 33, we need to pick only one. And we pick the one that's farthest in time. So maybe the 32 one compared to like the 41-year-old one. Yes. And then the person had to be older than 50 because that's our cutoff for like older adults. So if they're younger than that at the current time, then we cannot include them in our study either. Yes.
Yeah, very clear. Thank you.
You're welcome. Thank you for the question.
Okay. Anyone else with questions? Well, I have a quick question. Oh, no, I can save it for later. I just saw the time and like we're already running a little late. So if there is no more question, then on behalf of the Department of Linguistics, Faculty of Arts, Chulalongkorn University, I would like to thank Dr. Suphasiree Chantavarin for very, very interesting and intriguing and stimulating talk today. In the future, we would be really honored to have you here again to give another talk sometime.
I would be happy to. Thank you for the invitation. I appreciate it.
Thank you very much. So that's it for today. Thank you,
everyone for joining.
Thank you everyone for coming to the talk. Yeah, it's a lot of, there's a lot of people. There were like over 50, almost 60 people. So thank you very much.
Feel free to email me if you have questions or comments that we did not have time for today. I would be happy to address them.
Okay. Okay, that's it for today. Thank you, everyone. ขอบคุณทุกคนนะคะ
ขอบคุณค่ะ
ขอบคุณมากค่ะ
ขอบคุณค่ะ
ขอบคุณนะครับ
ขอบคุณค่ะยินดี